In this first video on projectiles, I'm just going to go through some of the key facts that you need to remember from Unit 2 that can be applied in this Unit 4 section. Effectively, a projectile is simply an object that has been projected at an angle to the horizontal and obviously has a horizontal and a vertical component. Usually we denote the angle to the horizontal as theta in this case, and an initial projection would be given as a speed of u. The two key CVAT equations that you'll probably need to recall from previous learning are V equals U plus AT and S equals UT plus a half AT squared. These will be used for derivations and also calculating component distances and speeds. The other thing you must be fluent with is vectors. As you can see from the first diagram there, we need to be able to resolve in the horizontal and vertical direction. So if we take our diagram at the top as an example, I would expect us to be able to resolve the horizontal component of speed as being u cos theta and the vertical component as u sine theta. Moving on from that, some of the key facts that we need to remember are that the only force that acts is gravity. Okay, as soon as a projectile is projected through the air, gravity acts straight away to drag that projectile back to the earth. We also use things like the projectile is a particle, which we've used in Unit 2. This is obviously to make our calculations more simplistic. Obviously, if you moved on to do this at a higher level, we would remove that idea of the projectile being a particle. Other things about the projectile is that we assume it is not powered. Obviously, it's got no engines or anything like that. And it's free to fly through the air. And mentioning air has no effect. And we discussed this when we were doing CVAT equations. We do not take into account the fact of air resistance. Other key things we need to remember is that a projectile will experience an acceleration due to gravity of 9.8 meters per second minus 2 vertically downwards. Okay, as soon as it's projected, it's obviously being dragged back down to the earth by the force due to gravity, and that is an acceleration of 9.8 meters per second every second. The other interesting thing to know is the horizontal component of acceleration is 0. So when you project a particle at an angle, then obviously it is being dragged vertically downwards, but the horizontal component has no action at all, because as we know, acceleration due to gravity is vertically downward. Okay, so that's very important to know. Other key things, and again it comes from CVATs in part 2, is that the maximum height a projectile can reach, which we'll call as Vy, is 0. So at maximum height, Vy is 0. That means that it's actually at that point where it instantaneously stops. If you need any more clarification on that, have a look at my CVAT videos on Unit 2. And that pretty much wraps up everything we need to know on Unit 4 projectile motion. I'll refer to these as we go through and derive any equations.